Good morning, Math 20s. This is going to be the first part of a two-part video where we are looking at applications of special triangles. So you should have this worksheet printed out titled Application of Special Triangles. And I will do this question here. And then in the second video, I'm going to do a question from your review package, which is involving special triangles as well. Okay? So let's look at this first question. The reason why I like this question is because we're first going to solve it how you would have done in grade 10. And then what we're going to do is say, okay, now in Math 20-1, 30-1, how would you solve this using special triangles? So what it says is it says two wires are connected to a tower at the same point on the tower. So pretend that this is your tower here, and they have two wires coming out of the tower at the same point, and each of those wires is connected to the ground. Okay, so I've represented that with this diagram, and it says wire 1 makes an angle of 45 degrees with the ground. So what I'll do is I'll say the triangle on the left, I'll call this one wire 1, and it says that that wire makes an angle of 45 degrees with the ground. So that would be a 45-degree angle there, and this would be a right angle triangle. Okay, so that's wire 1. And then what it says is wire 2 makes an angle of 30 degrees with the ground. So let's call this wire wire 2. And it says that that wire makes an angle of 30 degrees with the ground. And that triangle, again, is going to be another right angle triangle. Okay. The first part says represent this situation with a diagram. So I've got my label diagram, right? I've got my tower here, the two wires coming at the same point on the tower, and each wire makes a different angle with the ground. Okay, then what it says for B, it says if the point of the two wires connects to the tower 35 meters above the ground, are you able to figure out where the 35 meters would be on this diagram? So it says the two wires connect to a point on a tower 35 meters above the ground. That means that this would be the tower, and that's my 35 meters there. So the tower is 35 meters high. And what question B is asking is what's the length of each wire? And let's just pretend we were in Math 10C. We don't know anything about special triangles. How would you figure out the length of each wire? So what I would do for this question is we essentially have two right angle triangles. So I'm going to represent this left triangle by this diagram here, this right triangle by this diagram on the right, and I'm going to use SOHCAHTOA to figure out the length of wire 1 and wire 2. Okay? So for this first triangle, here's 45 degrees. There's my 90-degree angle. And this is wire 1, which I'm going to denote as being X. So let's label our triangle according to the given angle of 45 degrees. And I know that, sorry, this height is 35. So the 45-degree angle, remember it always stares at the opposite side. So this length would be the opposite side. And the 90 degrees is always directly across from the hypotenuse. Okay, so that would be the hypotenuse there. If I'm solving for x, I need to use, I'm going to box that side in, and you always box in a given side, right? So I'm going to box in this 35. So then I ask myself, okay, what trig ratio has opposite and hypotenuse according to sine, cosine, and tangent? And the one that has opposite and hypotenuse is the sine trig ratio. So when we set this up in grade 10, we always said, okay, the sine of a given angle is equal to opposite over hypotenuse. Well, my given angle is 45 degrees. So the sine of 45 degrees is equal to the opposite side, which is 35, and the hypotenuse is x. I'm not sure if you remember from grade 10, but if x is on the bottom, you can simply swap it out, and we're essentially cross-multiplying in one step here if x is ever on the bottom. So x is equal to 35 over the sine of 45 degrees. Okay, so let's figure out what the length of wire 1 is. 35 divided by the sine of 45. So 35 divided by the sine of 45 degrees. And wire 1 to the nearest tenth is 49.5 meters. So x, which is equal to wire 1, is equal to 49.5 meters. That's my length of wire 1. And I'm going to go up here now, 49.5. That would be the length of wire 1. Okay, wire 2. This would be wire 2. And because I denoted X as wire 1, I'm going to say, okay, well, wire 2, I'm going to put a Y there, right? So if this is wire 2, I want to calculate what Y is. They told me that this is a 30-degree angle. We know that the height of the tower is 35 meters. And now I have enough information to use SOHCAHTOA to figure out the length of wire 2. So according to my given angle of 30 degrees, let's label. This would be your opposite side. Across from your 90-degree angle is your hypotenuse. You always box in the side that you are looking for, and you always box in a given side. So which trig ratio has opposite and hypotenuse? It's the same trig ratio, so the sine. This time it's the sine of 30 degrees, and sine is opposite over hypotenuse, which is 35 over y. Okay, y is on the bottom, so you can just simply switch this out. Y is equal to 35 over the sine of 30. So let's figure out on our calculators what the length of wire y is. So 35 divided by the sine of 30. Oops. Sine of 30 degrees. So wire 2 is 70 meters in length. And sorry, that's equal to wire 2. So I'm going to go back up here, and wire 2 is 70 meters. Okay, so there's our answers there, and that's how we solve this, like I said, if we just had the knowledge of Math 10C. But what we're going to do now is we're going to do this exact same problem, but we're not going to use, well, we're going to set it up using SOHCAHTOA, I guess, but we're also going to apply our special triangles. Okay, so how would we do this exact same problem using special triangles? Okay, whenever you see the word exact, what that means is no decimals. Okay, and in Math 20-1 or 30-1, that word exact is your clue or your big hint, okay, that we need to use special triangles. And what that means is when we use special triangles, this is not an exact value, right? This is an, to have this as an exact value, we would want to have radicals in there. And in order to get radicals, that's going to be special triangles. So if we were doing trig for grade for 20-1 or 30-1, let's set up the triangles in the exact same way, but we're going to solve it using special triangles, okay? So wire 1, I had called this x. They told me that this was 45 degrees. This was 35 meters. And here's 90. So let's set this up one more time really quickly. According to 45 degrees, that would be my opposite and my hypotenuse. And we had the sine of 45 degrees is equal to 35 over x. Okay, now when we do this exact, you should know from lesson 4 what is the exact value of the sine of 45 degrees. Like, what is that number using special triangles? And if you forget, remember, we have to set up our special triangle. So which triangle would have the 45-degree angle? That was the 45, 45, 90, right? And what was the 45, 45, 90? What did I tell you you need to memorize? And that was 1, 1, root 2, right? So label your triangle according to 45 degrees, and the 1 and the 1s would be here, and root 2 is your longest side, so that would go there. The sine of 45 degrees if I said, what exactly is the sine of 45 degrees? So I'll show you what I mean. I could go to my calculator and I could say, okay, well, what is the sine of 45 degrees? That is not an exact value. That is what the sine of 45 degrees is, but it's not exact. So the sine of 45 degrees, using my special triangles, sine is 7 yellow rabbits. So the sine of 45 degrees, y over r, would be 1 over root 2. This is exactly what the sine of 45 degrees is. Okay, that's an exact value, and I could show you that on my calculator. 1 divided by root 2. Remember, exact values mean no decimals. So this number, written as an exact value, would be 1 over root 2. So what I want you to do is when you see this, you take this out, right? Because we know, according to our special triangles, exactly what the sine of 45 degrees is. The sine of 45 is 1 over root 2. And they told me that that was equal to 35 over x. So all I've done is I've taken out the sine of 45 and I've put in what exactly that would be, right? And that's equal to 35 over x. Now let's solve for x. Let's cross multiply. So x times 1 is 1x is equal to 35 times root 2 is 35 root 2. And then normally you would get rid of that number, but it's a 1. So x is equal to 35 root 2. That is the exact length of wire 1. And let's check if we were correct. If I go back to my calculator, here's what we had wire 1 was, right? But what would this be as an exact value? Well, we think it's 35 root 2. So let's double check. Is 35 root 2 the same as this number here? So 35 root 2, and it is, right? That number, 49.49, is exactly the same as that number. Okay, so wire 1 as an exact value is 35 root 2 meters. Let's do this exact same thing now and find how would we do special triangles to get the exact value of wire 2. Okay, so wire 2, that was 35, and it was a 30-degree angle, and we called this y. Right? So let's label according to SOHCAHTOA. That would be my opposite. Y would be my hypotenuse. And the sine of 30 degrees is equal to opposite 35 over y. Okay, the word exact, you look at this and it will always be a special triangle. 100% of the time when I say the word exact, you'll either have the number 30 here, 45, or 60. Those are the only numbers that you have to know what the exact number is. So what's the sine of 30 degrees? I need to take this out and I need to figure out, well, what exactly was the sine of 30 degrees? So I don't have it memorized, and nor should you. So let's put in 30 degrees. This special triangle would be the 30, 60, 90. Okay, so what did I tell you to remember for the 30, 60, 90? 1, 2, root 3. I'm going to label across from 30 degrees is 1. Between 2 and root 3, what's bigger? 2 is bigger, so it goes on my radius, and root 3 would go here. The sine of 30 degrees as an exact number, sine is 7 yellow rabbits. So the sine of 30 degrees is y over r. There's y, and that's r. So sine of 30 degrees as an exact number is 1 over 2. Okay, so what I'm going to do is I'm going to take out the sine of 30 degrees and let's put it in what that is as an exact number. So that would be 1 over 2. And that is equal to 35 over y, right? So sine of 30 degrees, again, I could show you on my calculator. So I'll just clear this. Sine of 30 degrees is 0.5. Right? So I just took out the sine of 30 degrees and I put in what exactly that would be. So now I have two fractions equaling one another, and I've got an unknown, which is y, so let's cross multiply. 1 times y is equal to 2 times 35. 1y is equal to 70. Divide this by 1 and this by 1. Y is equal to 70 meters. So the exact value of the second wire was 70 meters. Which wire is longer? Wire 2.